Question 2. A is a solution of trioxonitrate 5 acid. B is a solution containing 1.05 grams of anhydrous sodium trioxocarbonate 4 dissolved in 500 cm³ of solution. Put A into the burette and titrate with 20 cm³ or 25 cm³ portion of B using methyl orange as indicator. Record the volume of your pipette and repeat the titration to obtain consistent titer values. Tabulate your results and calculate the average volume of acid used. From your results and the information provided, calculate the 1. Concentration of solution B in moles per dm³. 2. Concentration of A in moles per dm³. 3. Mass of sodium trioxonitrate 5 that would be formed in solution if 1 dm³ of solution B were neutralized by solution A. 4. Volume of carbon dioxide at STP that will be liberated in 3 above. The equation for the reaction is as shown on the screen. In question 1, we saw how to calculate the molar mass of a compound that contains an unknown element in its formula, and also how to determine the relative atomic mass of the unknown element, and we also calculated the percentage by mass of the unknown element in the compound. Now, if you'd like to watch the first part of this tutorial, kindly check the link in the description. So in question 2, the only information you have about A is that it is a solution of trioxonitrate 5 acid. That's all, no other information about it. And then B, we are told that B is a solution that contains 1.05 grams of anhydrous Na2CO3 dissolved in 500 cm³ of its solution. Now, from this information provided, we don't know anything about HNO3, the acid, and for the base, we are given a part information that will help us calculate the concentration of the base in grams per dm³. But we are not given the full concentration in grams per dm³. Rather, we are given the amount or the mass of the substance that was dissolved in 500 cm³, which means that we have to convert it to what? Grams per dm³ using this formula. You can see that in question 1 we did not make use of this formula. So now in question 2, based on this question, we have introduced another formula. That's concentration in grams per dm³ equals to what? Mass times 1000 over volume in cm³. Using that as mass in grams over volume in what? dm³. Remember, this volume in dm³ is what is converted to 1000 over volume in cm³, because 1000 cm³ equals to 1 dm³. So now the first question therefore says we are asked to do what? In the first question we are asked to calculate the concentration of solution B in moles per dm³. So now, to calculate the concentration of solution B in moles per dm³, which of these formulae are we going to use? Let's look at it. Concentration of solution B in moles per dm³. 1. Concentration of B in moles per dm³. Fine. So, from this, can we calculate, do we know the concentration of B in grams per dm³? Yes, in a way, we are not given the actual concentration in grams per dm³, but we can calculate it from the information provided. Okay, now, do we know, can we get the molar mass of B? Yes, we know what B is. We are given the formula of B here, unlike the first question in part 1. Fine. Now, let's look at other questions. Now, can we use this formula to calculate the concentration of B in moles per dm³? Remember, CB is what we are looking for. Okay, let's see. Do we know C? Do we have CA? That's concentration of A in moles per dm³. No, we don't. Do we have VA? Yes. V is our titer value. Remember, VB is our volume of pipettes. NA over NB is the mole ratio in the equation of what? Reaction, which is 2 over what? 1. Now, but since we do not have CA, there's no way we can have two unknown in the same what? Equation. So we cannot use this. Fine. We have all the parameters that we need to find concentration in moles per dm cube here. We're just trying to check whether there's another formula that we can use here apart from this. Now, number of moles, concentration of this in moles per dm cube times volume in dm cube. Do we know the number of moles of B that reacted? No, so we cannot use this. Okay, that's the only. These are the only formulae that contain concentration in moles per dm cube. Fine. So now, to calculate this, it means that we are going to make use of what? This is concentration in grams per dm cube. That will be what? Divided by molar mass of what? B. Fine. So what's the concentration? By the concentration of B in grams per dm cube, concentration of B in grams per dm cube is given as what? The mass of B times 1000 over what? Volume in what? cm cube, because the volume we are given here is in cm cube. Fine. So what do we do here? And the mass we are given here is 1.0, so you substitute 1.05 times 1000 over 500. That gives us what? That will be 2.10 grams per what? dm cube. Every concentration value must, remember, must be in what? 3 significant word figures with the right word units. Fine. So from there, the molar mass, to calculate the molar mass of B, molar mass of Na2CO3 will be calculated as 2 times Na plus 1 times C plus 3 times what? O, that's atomic mass of oxygen. That's 2 times 23 plus 1 times 12 plus 3 times 16 gives us what? 2 times 23 is what? 46. That's 46 plus 1 times 12 plus 3 times 16, that's 48. If you calculate this, it should give us 106 grams per what? Mole. So with this now, we can then go ahead to substitute into this formula. Yes, can I substitute into this formula to find what? To solve for what? Concentration of B in moles per dm cube. And if we do that, we'll obtain concentration of B in moles per dm cube is equal to 2.1, right? Yes. That's 2.1 over 100 and what? 6. So that gives us 0.0198. Is it? Let's see. Yes. 0.0198 mole per dm cube to 3 significant word figure. Fine. So that gives us concentration of B in moles per dm cube. Then the next question says we should calculate the concentration of A in moles per dm. So now, since we have gotten the concentration of B in moles per dm cube, remember we are not given any other information about A apart from its formula, and we are now asked to calculate the concentration of A in moles per dm cube, which means that this is the only formula that we can use because we know the value of what? VA, and we know Na over NB, and of course our what? VB. So concentration of A in moles per dm cube, we are going to use what? CAVA over CBVB equals to what? NA over what? NB, of course, which equals to what? CAVA over CBVB equals to 2 over 1. Please don't jump any step. Don't jump any step if you must earn your full marks. Okay, so now this now gives us what? This gives us we are looking for CA, remember, right? We've substituted this the mole ratio here. So for we make CA subject to formula, that gives us what? CBVB times what? 2, right? All over what? VA times what? 1. So what would that give us? Our CB, the CB we calculated is what? 0.0198 times VB 25 times what? 2 all over VA. We don't know what VA is, so it depends on what your VA will be. And VA times 1. So that gives us what? 0.495 all over what? VA in moles per dm cube. Remember, your value must be in 3 significant figures. Fine. Now, the next question says, calculate the mass of sodium trioxonitrate 5 that would be formed in solution if 1 dm cube of solution B were neutralized by solution A. Fine. So, let's wipe this off. Let's write the equation of reaction. HNO3 plus Na2CO3 give us what? NaNO3 plus H2O give us plus CO what? 2. So we balance this, we have 2 here, 2 here. Fine. Now we are told to calculate the mass of sodium trioxonitrate 5 that will do what? That will be formed in solution if 1 dm cube of solution B were neutralized by solution A. So means that we are using what? We are using solution B to calculate the amount of sodium trioxonitrate 5 that will be what? Formed. So how do we go about this? First of all, what's the mole ratio here? Number of moles of Na2CO3 to number of moles of sodium trioxonitrate 5 is what? 1:2 from the equation of reaction here, which means that for every 1 mole of Na2CO3 that reacts, 2 moles of sodium trioxonitrate 5 will be what? Formed. Fine. Now, but the question says that will be formed if 1 dm cube of this solution is what? Neutralized by the acid. Remember, they were silent on the amount of on the volume of the acid that would be required to neutralize the base, but they give us the specific volume of the base that would be neutralized. So now, and to get the mass of this guy that will be formed, we need to first of all know the number of moles of the Na2CO3 that will be present in 1 dm cube of the base. So this is where this formula now comes in. Number of moles equals to what? Concentration in moles per dm cube times volume in dm cube. So we come here now. So number of moles, but number of moles of Na2CO3 equals to what? Concentration of B. Na2CO3 is that B, right? Times volume in what? dm what? Cube. So what's the B that we calculated? 0.0198 times volume. Which volume are we talking about? It is the volume in that question, in that particular question, that statement, right? Which is 1 dm cube. If they are said calculate the mass of sodium trioxonitrate 5 that will be formed if 500 cm cube of solution B were neutralized by the acid, then we use 500 cm cube. But since they say 1 dm cube, we have to make use of that 1 dm cube or 1000 cm cube. Fine. So that will be what times what? 1 dm. Any volume that is stated in that question, you convert it to what? Dm cube, and then use this word formula. Remember, this is in moles per dm cube. So let me correct this. That will be moles per dm cube times what? 1 dm cube. So this will go, leaving us with what? 0.0198 what? Mole, right? So now it means that from this relationship, the number of moles of sodium trioxonitrate 5 is equal to every sodium trioxonitrate 5 that will be formed, right? Then two moles of what? Of sodium. Am I right? Let's see. Means that yes, from this relationship means that the number of moles of sodium trioxonitrate 5 formed at every point in time will be equal to 2 times the number of moles of sodium trioxocarbonate 4 that is what reacted, right? So this will be so it means that since 0.0198 mole of the base reacted, it means that 2 times 0.0198 mole of the salt will be what? Formed, right? Which is what? That will be 0.0396 mole of sodium trioxonitrate 5. Fine. Now, but we are told to calculate what? Mass. The mass of sodium trioxonitrate 5. So the mass of sodium trioxonitrate 5, NaNO3, will be obtained from the formula of number of moles equals to what? Mass over what? Molar mass, right? So it means that mass here will be equal to what? Number of moles of sodium trioxonitrate 5 times what? The molar what? Mass of sodium trioxonitrate 5. What's the molar mass of sodium trioxonitrate 5? It is what? 1 times Na plus 1 times N plus 3 times oxygen. So that's 1 times 23 plus 1 times 14. That's the relative atomic mass of nitrogen plus 3 times 16, relative atomic mass of oxygen. So this gives us 23 plus 14 plus 48, and that should give us what? Calculate it, press it. You guys are sleeping, right? You are sleeping in my class. That is a taboo. So this will be 23 plus 14 plus 48, and that is 85. That gives us what? 85 grams per mole. So what do we now do? Substitute this value into this formula, right? So mass of sodium trioxonitrate 5 we go to what? Number of moles, which is 0.0396 times 85 times 85. That gives us what? 3.366 what? Grams of sodium trioxonitrate 5, which means that based on this titration, 3.366 grams of sodium trioxonitrate 5 was formed or would be formed when 1 dm cube of the sodium trioxocarbonate 4 is neutralized by the acid. Alright, then the last question says the volume of carbon 4 oxide at STP that would be liberated in 3 above. Of course, you must expect this question. Whenever you have a trioxocarbonate, a titration that involves a trioxocarbonate 4, right? Then expect a question on the liberation of carbon 4 oxide at STP, right? Just an application of your mole concept. So now what do we do here? The same way we use the Na2CO3 to determine the mass of NaNO3 that will be formed. We are also going to use the number of moles of Na2CO3 that would liberate a certain volume or the required volume of carbon 4 oxide. So, equation of reaction, number of moles of Na2CO3 to the ratio of number of moles of Na2CO3 to number of moles of CO2 is 1:1. And since we already calculated the number of moles of Na2CO3 as 0.0198 mole, right? 198 mole, sorry. So therefore, number of moles of CO2 is equivalent to the number of moles of Na2CO3 equals to what? 0.0198 what? Mole. Are we together? Fine. Now, but what were we asked to do? We were asked to do what? Calculate the volume of carbon 4 oxide that will be what? Liberated at STP in this reaction here based on the titration. So now, which means that, remember, the same way we use the relationship between mass and number of moles to calculate the mass of sodium trioxonitrate 5 that will be formed, we're also going to use the relationship between volume and number of moles to calculate the volume of CO2 that will be liberated. And that's what? Volume of CO2 equals to what? Number of moles of CO2 times molar what? Volume. And molar volume is the volume occupied by 1 mole of a gas at STP, which is a constant, and the value of 22.4 dmg, which is given in the question. So here we substitute. That will be what? 0.0198 times 22.4. That will give us what? 0.4435 dm cube. You can just say approximately 0.44 dm cube at what? STP. So, and that is that. So, these are just the applications of the likely questions that can come out in this year's 2022 NECO Chemistry Practical based on the instruction released by NECO. So we've come to the concluding part of this tutorial. If you obtain any value from this lesson, kindly hit the like button, subscribe to our channel, and turn on your notification bell to always stay updated with our new uploads, right? A wise man once said that happiness is a choice and not a result. So nothing can make you happy except you choose to, right? So our advice for you is to always stay happy, always make yourself happy, always remain happy till I see you when I'll see you.